Okay, so we learned about the slopes of lines in the last lesson. Now we're going to take a look at the slope formula. So we know that the slope is going to be the measure of the steepness of a line. The slope is a ratio of the vertical change, which we call the rise, over the horizontal change, which we call a run. If it rises from left to right, then it has a positive slope. If it falls moving from left to right, it has a negative slope. Anytime I just have a perfectly horizontal line, it's going to have a slope of 0. If I have a perfectly vertical line, it's going to have a undefined slope. This is the one that when you put in your calculator for the ratio, it's going to say error. And the slope of all line segments on a line, so if I pick any 2 points on a consistent line, they're going to be equal. So they're going to give me equivalent fractions for any 2 points that I pick. All right, so if I am developing the slope of a line segment, first, I'm going to take the point AB and use rise over run. So going from point A to point B, in this case I went up 1, 2, 3, and I went to the right 1, 2, 3, 4, 5, and 6. So I'm going to say that this would have a slope of 3 over 6 or 1 over 2 as a reduced fraction. If I'm stating what the actual coordinates are, well, the coordinates here are I have 1 and 8, and the second coordinates are 7 and 11. How can the rise of the line segment AB be determined using the y value at B and the y value at A? Well, to move from the y value at B to the y value at A, I'm just taking the difference between the two of them. So I'm just going to say it's going to be 11 minus 8. Here's a y value at B, there's a y value at A, which we can see here and here. And that's going to give me a difference of 3. How can I figure out the run? Well, once again, it's going to be how much did it change, so I'm going to take the x value at B, 7, minus the x value at A, which is 1, and it had a change of 6, which also matches the information that I have here when I did the rise and the run. If I'm using the results from C and D to write a formula which describes how the slopes of line segment AB can be calculated using its endpoint, well, I'm going to say the slope is going to equal the y value at B minus the y value at A divided by the x value at B minus the x value at A. If I'm calculating the slope of the line segment using this formula, then I'm going to say that the slope is equal to 11 minus 8 over 7 minus 1, which is going to give me 3 over 6, and I can reduce that down to 1 over 2. I'm going to use the other 2 points, or the other 2 line segments, to check this. So first thing, I'm going to take a look at C to D, and I'm going to say, well, this went down by 3, and right by 1, 2, 3, 4, which means that it has a slope of negative 3 over 4. When I look at E to F, here I had to go up by 1, 2, 3, 4, 5, 6, 7, 8, 9, and right by 1, 2, 3, which means it's got a slope of 9 over 3, which would also just give me a slope of 3. If I'm using the formula in E to verify this, well, I have to write out what the points would have been. So I'm going to say that the points for C are going to be 2 and 5, and for D is going to be 6 and 2. The point for E is 9 and 3, and the point for F is 12 and 12. So, if I'm using the same formula that I used in the last case, I'm going to say that the slope of the line segment CD is going to be the y value at D minus the y value at C over the x value at D minus the x value at C. The y value at D was 2. The y value at C was 5. The x value at D was 6. And the x value at C was 2. 2 minus 5 is going to give me negative 3. 6 minus 2 is going to give me 4. And this slope matches the slope that I found. If I'm going to do the same thing for the slope of EF, then I'm going to take the slope at F, or the y value at F, which is 12, minus the y value at E, which is 3, over the x value at F, which is 12, and the x value at E, which is 9. 12 minus 3 is 9. 12 minus 9 is 3. And I have a slope of 3, which also matches what I found. So, in math, we use the lowercase letter m to represent slope. This is going to carry through into grade 11 and in grade 12. Anytime in our functions we have the lowercase letter m, and it's the same thing on your formula sheet, it's always going to wind up representing slope. If the graph of a linear relation passes through points of P, which is we're going to call x1 and y1, and Q, which is going to be x2 and y2, then the slope of this is going to be, the slope, or m, is going to be y2 minus y1 over x2 minus x1, making sure that the coordinates that match up together are always stacked on top of each other. Or the slope of the line segment PQ is going to be yq over xq minus yp over xp. Once again, making sure that the points or the two values from the same coordinate are going to match up together. So, if I'm finding the slope of line segment which passes through a point of G and H, then it's saying it wants me to state that it's going to be the y value at H, negative 2, minus the y value at G, which is 8, over the x value at H, which is going to be 7, minus the x value at g, which is going to be negative 3. On the top, negative 2 minus 8 is going to give me negative 10. And on the bottom, 7 minus negative 3, well, the double negatives is going to be the same as 7 plus 3. That's going to be over positive 10. Negative 10 divided by positive 10, I have a slope of negative 1.